Welcome back to Designing AI-Driven Personalized Learning Environments course. In this video, we'll talk about limitations of item response theory as a learner model. In the last video, we saw item response theory. It is able to collect, difficulty level of the questions, also the learner's ability using maximum likelihood probability. So, but is it good? Is that able to do well because it is matching the learner ability based on the response to the each questions, each items, and it's also matching the right kind of item. It's very interesting. No, it's like it's simple mathematical model we can run on the systems, which could, if you have a set of 100 questions created, it can keep on matching. The students can learn better. Is this good? Or what are the limitations of item response theory learner model? So think about this for a couple of minutes and try to write down your answers. What are the limitations? Think a bit more. Take a few minutes to think about it, where the data comes from, all those things. Then continue the video. So IRT was designed for summative assessment, for example testing. That's why it is used in GMAT, GRE, SAT exams. It is not a formative assessment in the sense it's not used to teaching. What I mean here is that IIT is trying to match your testing skills to test your knowledge quickly. Okay, if you have done this, if you already know the topic, give the exact match. You could learn actually by doing some kind of questions, but the system should give also feedback to you, send feedback in terms of remedial content, why you are failing. That's not a part of IRT. The item response theory is trying to match your ability with the difficulty level. That's all. It is not trying to understand why, or it is not trying to understand how to resolve that. So the IRT is very good for testing systems, and that has been used in GRE, GMAT, SAT, and yeah, it's how it has been used. Another issue is that IRT models assume that students' underlying ability remains constant for the duration of assessment. It's not actually, now it adapts it, but most of the system which created in IRT, it assumes like that. A set of the set of improvement in the IRT, for example, set of idea and IRT has been improved, but initial IRT systems based on the student's ability, which kind of say your ability is 2, I'll give all the 2 questions now. After say 10 items or 20 items, recalibrates your theta. It is not recalibrating your theta at every item you answer, but that would increase a lot of complexity of the systems. But now it has been done a bit. So and now the IRT can do that, but in general the system which we talked about as assumes that the learner ability is theta, is constant. The another issue is that if the theta increases, suppose the learner ability from -1 to 2 suddenly increased, it's an error. It's not actually happening, because suppose if I have given 5 questions, initially you had a very poor performer, say -1, and the 5 questions, 5 hard questions, you have done a fantastic job. Your theta might increase to the 1 or 2, good performer, and the system considers this is some error. It's not actually possible to increase it. For system, the theta has to be constant and moving in certain pace. In a PAL, we want the theta to increase. We want the student's ability to keep changing, and it's not within the range. It has to go further. It has to keep moving. That is the idea of the PAL. So that's a one difference also we see in static learning ability in IRT. Another big issue is that cold start problem. I told that developer assumes that, or the designer assumes, the expert assumes that difficulty of each question is 0.8. That it's of a 0.1 or 1 or 2. That is a cold start problem. And if I want to conduct the IRT, first I need to collect data from at least say thousands or 10,000s of learners on this particular item. Their response on the voting is computed, then the difficulty level is changed. Otherwise, whatever bias the experts have on the difficulty level is assumed as a difficulty level. So we cannot completely assume the difficulty based on the expert or designer. Instead, we need to do that and implement into thousands of students, get those data and come back. That is how this, this item response has to be changed. So the cold start problem is one of the major issue in IRT. If you want to use IRT, suppose you have created a MOOC system, you have created some 20 questions, you are the designer or expert in the particular topic, you assume this is high level, medium level difficulty, and if it is not matching with the difficulty level or the expectation of the learner, then the whole issue system will not work. So we need to test it with some thousands of learners or at least hundreds of learners, get their opinion on the difficulty level, tune it, then you test it. If you do directly, you will miss the idea. If IIT is taking a photograph of students' knowledge, for example, IIT tells the learner ability based on the items they answered, say 10 items they answered, what kind of mathematical tool would act like a video camera? If you understand what are the difference? If IIT is just a snapshot, saying the learner is 0.8, the learner is 1 now. But what I want is, I want to see not just learners 1, how learners become 1, how learners 1 is going to be 2. What is the tool we need to understand learners progress or the transition from one state to other? What is the video camera would be? Can you think about the next mathematical tool which is needed to capture these changes? The student tracing is needed. Pause the video and try to think about what kind of mathematical things we need for that. That mathematical tool will be part of our next lecture, that is Bayesian noise tracing. That will be week 4. We'll talk about that in detail, how the learner's progress has been captured. The resource for this week 3 courses, all the IRT systems, this learner modeling approach, I would recommend these 2 papers to read, these resources if you're interested, and this would help you to understand how the learner modeling has been useful, has been part of the PAL for long years, and how you can use IRT to adapt the content or match difficulty level with the learner's ability. Thank you.